Hello there, welcome to Simplifying Complex Fractions. Everybody's favorite thing in algebra. There's two methods for simplifying complex fractions. In this video I'm going to cover one method, the first method. I will do another video where I'm covering the second method. In both of these videos I will do this exact same complex fraction, simplifying them using each method. To show you, you can use any method you want, either method, to simplify complex fractions. Okay, so the first method is where you get one single fraction, numerator and denominator, and then you treat it just as a dividing fractions problem. Okay, so here's my first example. The idea is to figure out where your big fraction is. Okay, here's my fraction bar. So you can see in the numerator I have two terms, and in the denominator I have two terms, and in each location one of those terms is a fraction. Okay, so what we need to do is in the numerator get these two terms and turn them into add them by getting a common denominator and turn it into one single fraction. So I can think of that 3b as being over 1. And so what I need to do is I've got these two fractions that have a denominator of a and 1. So the least common denominator of these two fractions in the numerator of my big fraction would be a. Okay, so I'm going to create two equivalent fractions that have a common denominator, have the common denominator of a. Well, my first one already has the common denominator, so the numerator stays the same. In my second fraction, I need to multiply by a because so that I can have my common denominator of a. So 1 times a is a in the denominator. 3b times a is 3ab. Okay, so I'm going to do the same thing in the numerator. You can see then, once again, I've got these two terms. We could think of that b as being over 1. And I need then two fractions in the denominator that have the common denominator, which once again is a. 1 and a, the common denominator is a. Okay, so I need to take this first fraction and multiply by the common denominator in the top and the bottom. So in the top I have a times b is ab, and then a times 1 would give me a. My second term is a fraction. It already has the common denominator. Okay, so in the two fractions in the top and the two fractions in the bottom both have common denominators. Therefore, we can go ahead and add those fractions. Okay, so in the top, I have a denominator of a. It stays the same. Remember, we add the numerators. So when I add the numerators, I'm adding b plus 3ab. And in the denominator, I'm adding those two fractions. They have a common denominator of a, so I'm adding the numerators. So I'm adding ab plus 2b. They're not like terms, so I can't combine those. Okay, so notice how I have one single fraction in the top and one single fraction in the bottom. Okay, my fraction bar, remember, means divide. And when we divide fractions, remember that's this, we don't typically divide fractions, we multiply by the reciprocal. Okay, so instead of taking my top rational expression divided by my bottom, I'm going to take the top rational expression and multiply by the reciprocal of my rational expression, the denominator. So I'm going to find the reciprocal, which leaves me with a over ab plus 2b. Okay, so you can see now we're multiplying rational expressions. So using this method, you have to add rational expressions and multiply them. So it's a nice review of all methods. Okay? If you recall, when we multiply rational expressions, first thing we have to do is factor all of our polynomials. First one, in the numerator, I can factor out a common factor of b, which leaves me with 1 plus 3a. In my second rational expression, the denominator, those two terms, have a common factor of b. So if I factor out a b, it leaves me with a plus 2. Once everything's factored, I can divide out common factors. So I divide a b out, and I divide an a out of those numerators and denominators. And then we can multiply straight across the top. 1 plus 3a times 1 is 1 plus 3a. And 1 times a plus 2 is a plus 2. So here is our simplified. We simplified our complex fraction, and here's what we have. Nice rational expression that is simplified. Okay, let's try one more example. All right, so in this case, I have two fractions in the top and two fractions in the bottom. Okay, so in the numerator then, I need to get one single fraction, and notice how my denominators are different. I have a denominator of x and a denominator of y. Remember, if your denominators are different and have no common factors, the least common denominator is the product of those two. So of the two fractions in the numerator, the least common denominator is xy. So I'm going to take my first fraction times y, because that's the factor that's missing, which y times 1 is y in the numerator. And my second one, I'm going to multiply by x, because that denominator is missing the factor of x. So that leaves me with 1 times x is x in the numerator. So I've got a common denominator for those two fractions. I'm going to do the same thing with the two fractions in the denominator of my big fraction, my rational expression. Once again, my two denominators, y squared and x squared, have no common factors. Therefore, the common denominator is the product of those two. So now I need to multiply those fractions by whatever factor is missing to get those common denominators. Well, my first fraction, I have a y squared. I'm missing an x squared. So I'm going to multiply the numerator and denominator by x squared. So when I do that, I have x squared times 1, which is x squared, over my common denominator. And in my second fraction, 1 over x squared, I notice the denominator is missing a y squared. So that's what I'm going to multiply top and bottom by. So on the top, I multiply 1 times y squared is y squared. Okay? So I'm ready to subtract those fractions in the numerator and subtract those fractions in the denominator. Okay? Notice then that when I subtract here, my fractions have a common denominator. Denominator stays the same. We subtract the numerators. And we have y minus x, because y and x are not like terms. Okay? Same thing in the denominator. Those two fractions have the common denominator of x squared, y squared. And when I go to subtract, I have x squared and y squared, but they're not like terms, so I cannot subtract them. So we can see then that we have one single rational expression, a fraction in the top, one single rational expression or fraction in the bottom. Okay, so the idea is we're dividing rational expressions or fractions. So remember to divide two fractions. Instead of taking the top divided by the bottom, we take the top fraction and we multiply by the reciprocal of the bottom. And then we're multiplying rational expressions which before we can ever multiply rational expressions, we have to factor all the polynomials that are factorable. Okay, so it looks like y and x, y minus x, we cannot factor that, it's prime. xy is a monomial, I don't factor those. X squared, y squared is a monomial. But x squared minus y squared is a difference of two perfect squares, which factors into two binomials that are called conjugates, basically a sum and a difference of the same two terms. And now that everything's been factored, we can divide out common factors. Okay, so here's a little, this is kind of a tricky spot right here. Y minus x is not the same as x minus y. Okay, subtraction is not commutative. But if you recall, you can rewrite y minus x so that it has a factor of x minus y. Basically, if you take negative 1 times y minus x, whoops, I'm sorry. If you take and factor out a negative 1, it becomes x minus y. Okay, or basically those factors are opposites. So what I can do by rewriting the numerator as negative 1 times x minus y, we can then divide out that common factor of x minus y. Okay. Then here I have 1x and 1y in this in the denominator of my first rational expression, and I have 2 x's and 2 y's in the other. So I'm going to divide them both by xy. xy divided by xy is 1. X squared y squared divided by xy is xy. And then we multiply. Negative 1 times xy is negative 1xy. And in the bottom, I basically have 1 times x plus y times 1, which is x plus y. Whoops, not 4. It's a y. All right? So I notice I have no common factors. Okay? In the top, I have xy as a factor. In the bottom, remember, factors are multiplied. So in my denominator, x and y, it's x plus y. That's one single binomial factor. So this is what we get when we simplify that complex fraction.